All right, this is going to be acids, bases. We should be getting done with this one fairly quickly. So let's go ahead and get into it. They're everywhere, just like we saw in the video on acids and bases. All right, an acid. I want you to divide your paper into two sections, and I want you to call one acids and bases. So like up here, here's your paper. Divide your paper, put acids on one side and bases on the other, and then we're going to fill in little I want you to put it in bullet statements, okay? Because we're going to add a few things to it. So divide your paper, acids on one side, bases on the other. Leave a little bit of space at the bottom because we're going to put something down here at the end, okay? So let's get started. Acids. We'll start with this side over here, acids. An acid is a solution that has an excess of hydrogen ions. We also, I want you to make sure you put this down. We also have hydronium ions. Okay, hydronium ions are H3O plus ions. Okay, and that's what really kind of sets apart an acid from a base, and we'll talk more about that in a little bit. The more hydrogen ions you have, the more acidic the solution. So the hydrogen is what's causing the acids. Again, remember we talked about in reactions, we talked about acids and bases, and acids have an H to start it. So like HCl, where's my thing? HCl, H2SO4, and all of you asked you to do is look for these H's. Well, now we're going to ask you to go a little bit further. Why do we have the H's? Why is the H is an acid? Well, because it creates hydrogen ions in solution. And we talked about what solutions were. It's where we have dissociation of and ionization in solution, where they kind of break apart and water kind of takes over, and when the water evaporates, they go back together. Okay, so here are some simple properties to write down in bullet statements. So again, here's your paper. You're on the acid side. You're going to just kind of bullet these statements right here. One of the things that you need to know is they are sour in taste. They do conduct electricity. They're very corrosive. And some of them react with metals, okay? They turn blue litmus paper red, and they have a pink indicator. Okay, so I want you to add all that to your notes. So if you need to stop the video, go right ahead, okay? All right, some uses for acids. You can kind of put examples. So like here's our paper, okay, acids, and you have all your bullet statements. We have this little space right here. Put examples down here. So acetic acid is vinegar. You get it from lemons and limes, which is citric acid. Absorbic acid is what we need in our body. Sulfuric acid is for fertilizer, and of course we have car batteries. Those are some examples. You can put as many as you want, okay? All right, so again, here's our side here. And now we're on the bases side. A base is a solution that has an excess of OH ions, okay? So OH again is a hydroxide. And what's going to happen is if we have more hydroxide ions, then we're going to be more basic, okay? So the higher the OH concentration and less hydrogen we have, the more basic it's going to be. It usually, remember we said it always ends in hydroxide, like sodium hydroxide, lithium hydroxide, okay, barium hydroxide. Okay, so they're all bases here, okay? So another word for base is an alkali. Okay, so just kind of keep that in mind. Bases are substances that can accept hydrogen ions. So we're going to talk a little bit more about that in another video. And when you have hydrogen and hydroxide, you get H2O, water. Okay, here are some properties of a base. They feel slippery, so a lot of your soaps, okay, they taste bitter. They're corrosive. Just like acids, they will they can be very, very dangerous. This one right here, ammonia, sorry, you really don't want to use that with bare hands, and you don't want to be in a closed off space with it either. They can conduct electricity, so think of like alkaline batteries. They do not react with metals, and they turn litmus paper blue, red litmus paper blue, and they usually have a purple or blue indicator when we have when it's in solution. Okay, stop it if you need to and go on and keep going. All right, so bases are soaps, ammonia, cleaning, most of your cleaning products. Okay, they OH ions interact strongly with certain substances such as dirt and grease. That's why they're so good at being cleaning products. Here's one, chalk and oven cleaners are examples of familiar products that contain bases. So like your antacid tablets. I don't know if I spelled that right, but Tums. Okay. Your blood is also basic. Okay. All right. So how can we tell which is an acid or a base? I want you to draw this scale in your, I want you to draw at the very bottom where I said leave some space. I want you to draw yourself a line. Okay. It goes from 0 to 14. Right smack in the middle is 7. That is water. Okay. Everything from water to 0 is an acid. Everything from water to 14 is a base. Okay. The higher you get, the lower you get in the numbers, this is the most acidic. So more H plus ions or H3O plus ions, okay? The more you go this way, the more basic. Okay, so those are you have more OH negative ions. Okay, so here's some things. The pH scale ranges from 0 to 14. Acidic solutions have values below 7. Anything below 7 is considered acidic. A solution with a pH of 0 is very acidic, and anything at 7 is neutral. Pure water is at a 7. Basic solutions have anything above 7. Okay, so on this scale you can kind of see where everything falls. It doesn't mean because it's down here at 2 that it's dangerous. It just is more acidic, has more hydrogen ions, like lemon juice. We eat lemon juice. I mean, we can drink lemon juice, we can eat lemons. It's not hurting us. However, you get to a 0 hydrochloric acid, it might hurt you a little bit more. Okay, soap we use, it's 10. But drain cleaner, you really don't want to touch it too much because it can harm your skin. All right. I want you to just kind of write this down. A change in a pH of 1 pH unit represents a 10-fold change in the acidity. So like in the video, it changes times 10. Okay. For example, one solution of pH 1 and a second is pH 2. The first solution is not twice as acidic, it's 10 times more acidic. Okay. And I believe we're almost about done. A reaction, of course, is called a neutralization reaction. We've learned about that. And we make a water and a salt when we neutralize. And this is just some information if you want to know what kind of salts and what they're used for when we do have a neutralization reaction. Not going to require that at all, but if you want it, you can have it. Have a good evening.